Alrighty, so today we're going to talk about comparing fractions, and in your vocab you talked about the means extremes theorem, so that's what we're going to use to compare fractions. We're going to put them in order too. So let's take a quick look here. These two, obviously you know that 9/11 is bigger than 6/11, but I wanted to show you using the means extremes theorem how that works. So 9/11 and 6/11, and remember we start in the lower left, multiply up diagonal, write the answer over here. So that's 66. Then we start in the lower right, multiply up diagonal, write the answer over here, which is 99. Now because 99 is bigger than 66, that makes 9/11 bigger than 6/11. So it's proof to you it actually does work. Now sometimes you're going to have negatives. Oh my gosh, why couldn't I think of the word? You have negatives. So in this case, I have -1/2, -1/10. Here you're going to think backwards. I know you probably all know that -1/2 is technically smaller, right? Because it's farther to the left on the number line. But let's talk about how that works. What I want to talk about first, though, is the fact that you should probably assign that negative sign to the upper number. Okay, assign to the upper number on a fraction. That'll help make this make more sense. So we get 2 times -1, which is -2. And then over here, we get 10 times -1, which is -10. Now we all know that -2 is bigger than -10, right? Farther to the right of the number line. That makes -1/10 bigger. Now if you don't like that, ignore the negatives, do the cross multiplication, then just think backwards, right? So if I ignore the negatives, I'd have 10 and 2. Well, 10's bigger, but since they're negatives, I think backwards, so -2's bigger. That's another way to think about it. Alrighty, so here, again, if you'd like, you may make, common denominators. You can make 40s out of them and compare them that way. Or again, you could use means extremes theorem. Something I want to tell you too, by the way. Let's say I gave you mixed numbers. Make them improper first, then compare them. But anyway, so let's take a quick look here. We start out in the lower left. We have 8 times 7. You write that over here, and you get 56. Down here I have 10, upper left, times 5, which is 50. If I can get it straight. And again, we know 56 is bigger than 50, so 7/10 is bigger than 5/8. And again, if you want to go with common denominators, you're welcome to do so. Just a nice little trick, though, there. Again, if it's a mixed number, let's say I had 2 and 1/3, comparing that to 2 and 1/5. Make them improper first. So all you would do is 2 times 3, right, which is 6, so that becomes 7/3. And over here, 2 times 5 is 10, so 11/5. And then you could use your means extremes theorem. So make them improper first, then compare them. Go ahead and pause here, head into class kick. I've got a couple for you. Alrighty, so we're going to, again, make comparisons of fractions here. And as a reminder, we're just going to use that means extremes theorem. And always start it doesn't matter, lower left, lower right, multiply up and over. So 28 here, 6 times 5, 30 over here. 30 is bigger, therefore 6/7 is bigger. Next one you had here, we had 2/3 and 3/4. 2/3 and 3/4. Starting down here, 4 times 2 is 8. 3 times 3 is 9. So 3/4 is bigger. Now then, the last one, you had some negatives involved here. So, and I always, again, I assign the negative with the top. And that way it makes it, you go the right direction, let's say that much. Alrighty, so 10 times -3 is -30. 4 times -7 is -28. And we know that -28 is larger. There you go. Continue for another example from me. Alrighty, so here we're going to put numbers in order, smallest to biggest. And I have -1/2, 3/4, -1, and 2/5. Now, things to think about at the beginning here. First off, the two negatives have to be smaller than the other numbers, right? So -1/2 and -1 have to be smaller than the others. Now, which one's smaller? Well, you guys should know that negative 1/2 is a smaller number because it's farther to the left of the number line. So that wipes out the first two right off the bat for us. So then we just have to go back and determine 3/4 and 2/5, which one's bigger? So 3/4 and 2/5. And again, that cross multiplication is pretty useful. 5 times 3 is 15. 4 times 2 is 8. That makes 3/4 bigger. So if I'm going from smallest to biggest, next I'm obviously going to have 2/5 and finish it off with 3/4. So smallest to biggest. Pause, go ahead and head into class kick. I've got another one for you. Alrighty, ordering these from smallest to biggest. So first off, we know that 1 is bigger than all these other fractions. So that's going to be my biggest number. So I don't have to sweat that or consider that one in there. So I've got to decide what's bigger, 2/3, 1/6, 5/12. Well, I don't know how we're going to get started on here. We know for sure, some things to think about. We know for sure that 5/12 is less than 1/2 because 1/2 is 6/12. We know that 2/3 is definitely bigger than 1/2. So it's figuring out where that 1/6 is going to fall. Actually, you know that 1/6 is also bigger than 1/2 because 1/2 is 3/6. So it kind of gives us some idea of where to go, where to get started here. So out of these, if I need to compare them, let's say I'm not sure with 2/3 and 5/12. Let's say I'm not sure. So you could do that cross multiplication to figure that out. So you could say 2 times 12 is 24. 3 times 5 is 15. So we know that 2/3 is bigger. So let's take a look at that 1/6. Where does it fit between, let's say, 5/12 and 1/6? So 1/6 and 5/12. 1 times 12 is 12. 6 times 5 is 30. So 5/12 is bigger. So if 2/3 is bigger than 5/12 and 5/12 is bigger than 1/6, that makes 1/6 the smallest. So in this order, 1/6, and then 5/12, and 2/3, all of which are smaller than 1. Smallest to biggest.